Hi friends, welcome back to ElectrAspirant and assistance to electrical students for objective type exam preparation. It is an initiative of Department of Electrical and Electronics Engineering of Christ College of Engineering, Irinalakuda. In this video, we are going to go through the questions of 41 to 60 of Assistant Engineer Kerala PSC Examination 2014. Let's go through the first question, 41st question. More relay is usually employed in the protection of. The answer becomes C, that is long transmission lines. More relay is normally called as admittance relay or high speed relay, and it is mainly used for the protection of long, extra high voltage or ultra high voltage heavily loaded transmission lines. The short transmission lines are normally being protected using the reactance relay, and medium transmission lines are being protected using the impedance relay. This is regarding the first question, so the answer becomes C, long transmission lines. Let's move on to the next question. For question number 42 remains cancelled for PSC. Let's move on to the next question, 43. 43rd question is per unit value of any quantity. We have studied about PU quantity in power system analysis papers. PU quantity or PU value is the actual value to any quantity in any unit to the base value of the same unit. We have studied that the per unit value is defined as actual value divided by the base value. The only thing is both should be in the same unit. So your answer becomes B. Let's move on to the next question, question number 44. A relay which operates when the alternating current exceeds a certain preset value is called. So it is mentioned that the alternating current is exceeding a preset value. So we can say that the current is exceeding the preset value, and the answer becomes A, that is overcurrent relay. So overcurrent relay is used for the detection of the increase in the alternating current above a preset value. So that answer becomes A. Let's move on to the next question, question number 45. In question number 45, it is a small problem. A 10 MVA generator has a power factor 0.866 lagging. The reactive power produced by it will be. We know that the given value 10 MVA is actually the apparent power, that is S, and the given power factor value, that is cos phi. Okay, so we know the equation for reactive power Q, and the equation for reactive power Q is equal to S into sin phi. S into sin phi. So 0.86 is actually a common value, and it is normally cos 30. So from that we can obtain the value phi. Cos 30 means phi is 30. So we can easily find the answer for this one, S into sin 30. Sin 30 value is 1 by 2. So answer is 10 into 1 by 2, which becomes 5 MVAR. So MVAR shows the reactive. MVAR shows the reactive unit, that is megavolt ampere reactive, but in the answer it is just mentioned as 5 MVA, so we can tick the option C. Answer C, 5 MVA. Let's move on to the next question, that is 46th question, and the question is corona loss in HVDC transmission compared to the AC transmission is. So we know that the answer is low, that is answer is B. So what is the reason for this one? Corona loss is directly proportional to F plus 25. Corona loss is directly proportional to F plus 25, which means it depends upon the frequency. So for a DC transmission, the frequency will be 0, which means we can say that the corona loss will be very low when compared with an AC transmission line. And for an AC transmission line, for a DC transmission line, the loss will be very low. So the answer becomes B. Let's move on to the next question, question number 47. This question number 47 remains cancelled for PSC, so that we can move for the next one, 48th question. Compared to a closed loop system, an open loop system is. We know that when we are comparing with a closed loop and open loop, the open loop is less accurate when compared with a closed loop system. So the options B and D remains, and from which we know that an open loop system is more stable when compared with a closed loop system. So your answer becomes B. So for the question 48, the answer is B. Let's move on to the next question, question number 49. In question number 49, this question also remains cancelled for PSE. So let's move on to the next question, that is question number 50. Okay, the main application of transfer function is in the study of. The transfer function study mainly helps in analyzing both behaviors, that is the steady state behavior as well as the transient behavior of a system. So the answer for this question remains B, and answer for 50th question is B. Let's move on to the next question, question number 51. In the question, given the system specification in time domain, which is the best approach in time domain? You can go through the options. The answer is actually B, root locus criteria or root locus method. Root locus is used for showing the time domain approach. In time domain approach, it is very easy. It is very useful for analyzing the system. And the Nyquist plot and Borde's plot are actually frequency domain plots. So that is regarding question number 51. In question number 51, the answer becomes B. It is a time domain plot. The next comes question number 52. The bandwidth of a control system can be increased by. The answer is using a phase lead compensator. That is answer is B. It is actually a high pass filter. It is a high pass filter by which we can easily say that the bandwidth of the control system will be increased by using B. Okay, so let's move on to the next question, question number 53. Servo motor differs from the other motors since it has, answer is B, low inertia and low torque. So servo motors, we already know it is normally used for robotics. Main applications are robotics, and the main important characteristics of this one is it is having low inertia and low torque when we are comparing with the other type of motors. So let's move on to the next question, question number 54. This question also remains cancelled for PSE. So let's go on to the next one. This 54th question, 55 and 56 remains cancelled for PSE. So let's move on to the next question, that is question number 57. Hayes bridge is particularly used for the measurement of. Hayes bridge is actually a modification of the Maxwell's bridge, and the answer for this question is actually A. So Hayes bridge is used for measuring the self-inductance actually, but as it is asked, particularly used for the measurement. So this is particularly used for the measurement of inductance where the impedance phase angle is very large. If the phase angle of the impedance is large, such inductance values can be easily measured using the Hayes bridge, and it is a modification of the Maxwell's bridge. So that is regarding question number 57. Your answer is A. Let's move on to the next question, question number 58. Operation of Q meter is based on. Answer is C, series resonance. We have studied about Q factor, quality factor, and this quality factor mainly depends upon or it is directly related to resonance. And from this you can easily find out the answer. The answer is C, that is series resonance. Let's move on to the next question, question number 59. At low power factor, dynamometer type wattmeter will cause. So for a low power factor, what is happening for a dynamometer type wattmeter? During the low power factor, the inductance value of the potential coil causes a serious error in this reading, and which will cause, so there is a very high error during this low power factor due to the inductance of the potential coil. So the answer for this question becomes B. 59 answer is B. Let's move on to the last question, that is question number 60. The observed signal in an oscilloscope should be applied. Answer is B, across its Y plates. When we are applying the signal across the X plate, if the frequency of the applied signal is more than 16 Hz, what happens that it will be a horizontal line. And if it is applied across both the plates, what happens is it will be an oblique line. And about the other two options, that is horizontal amplifier and trigger circuits, are only two different blocks in this oscilloscope. So your correct answer becomes answer B, across its Y plate. When the signal is applied across the Y plate, the correct variations of the voltage is being noted. So that's all for today's section. Thank you everyone for listening. Hope you understood. We will see you again.